So today we will discuss here about a technique called bright field. Hey, everybody, please settle down. Please keep quiet. Take your places and please keep quiet. So today we will study a technique which is called bright field and polarized microscopy. It's a technique which is used to analyze or to visualize any object that we cannot see with the naked eye. So first of all, what is a microscope? It's basically an instrument which is used to examine or visualize those objects that are too small or that are too small or too tiny to be visible in the naked eye. And the word microscopy, it comes from the two Greek words. Micro, it means small, and scope means is to visualize or to view. And normally the most common microscope that we use in our laboratory purposes, in our day-to-day lives, is the optical microscope. Optical microscope is a microscope or as an instrument that basically employs particular things called lenses. You know automatically about lenses. You have already studied in your classes, in your lower classes. So lenses are basically like they are the tools which are used to refract the visible light, and therefore when the visible light will pass through the lens and it will hit the object, then the object will get illuminated, and from that we will be able to visualize the images. So basically microscope are of two main types depending on the lens. So the single lens microscope that we have is called the simple microscope, and the dual lens microscopes are called the compound microscopes. Now compound microscopes can further be divided into light microscope and electron microscope depending on the illumination source. So if the illumination source is a visible light or light basically, then we categorize it as a light microscope. If your illumination source, that is basically in microscope, you have to illuminate the sample, or you have to do in such a way that the sample gets visualized. Okay, so electrons are used in electron microscope in order to visualize your image or your object or specimen. So in the light microscope, we have two main parts, or basically the three main parts. So bright field, polarized, and fluorescence. And also in the recent times, with more modifications, came the dark field and the phase contrast microscopy. We will study one by one in the details in the next classes. And electron microscope we have like the scanning and transmission also, and also we have a confocal microscope. So these are some of the basic classification of the microscopes that we use in our day-to-day lives or in our day-to-day practical like practical experiments in order to understand the how a sample or how a specimen looks like. Now we already know about the parts of a microscope. First we have an eyepiece. So eyepiece is basically the part from where we try to visualize or see the things. And we have a adjustment. We have a nose piece, which is basically helpful to to set our objective lens. And then we have the objective lens, which helps us to capture the light from the specimen. Okay, we have a diaphragm, a condenser. Then we have an illuminator or light source, and these are some of the things. And the most important part we have is the fine adjustment and the coarse adjustment. So fine adjustment and the coarse, I will explain you when I will show you in the practical. So this is basically what these are knobs which are used to adjust our image so that we can get better resolution and better clarity images. And these are some of the parts and their functions. So first we have an eyepiece, or which is called ocular lens, which helps us to focus the image from the objective lens. Basically objective lens, what it does, it captures all the light that is passing from the specimen. So what it does is, it helps us to capture the light. And the eyepiece is the piece, or you can say is a part of the microscope that helps us to visualize what we are seeing in the specimen from the objective lens that the light is coming. Okay. Then we have the objective lens, which helps us to get a clear and a clarity proven image. And then we have two focusing knobs, which is very, very important. Whenever you are doing any microscope experiments, you need to understand that there are two adjustments. One is called the fine adjustment, which helps us for better clarity. One is called the coarse adjustment for adjusting the magnification of your sample. And then we have the stage. This is called the sample. So I'll show you in the later parts, where we can adjust the positioning of the sample with respect to the objective lens. We also have the condenser, which is mounted below the stage so that the light can be focused onto the object. And then we have the arm, and also we have an aperture diaphragm and a light illuminator. So light illuminator is a light source which helps us to illuminate the sample so we can see that what the microstructure of the sample is and what kind of specimen we are dealing with. So this is basically the working mechanism. And so there are basically like three optical pieces that are very important in a compound microscope. One is called the condenser lens, then we have the objective lens and the ocular lens. So as you can see in the diagram, so what the first thing is that condenser, what it does, it basically helps us to illuminate the object by converging a parallel beam of light from the source that is coming. Then we have the objective lens. So objective lens, what happens, it creates a magnified, an inverted image of the object. And the ocular lens, what it does, it helps us to magnify the image that is formed by the ocular lens. So all these things are very important in order to get a clear and a clarity image of the specimen that we are dealing with. And the total magnification power, as we can see from the formula, is basically the magnification of the objective lens multiplied by the magnification of the eyepiece. So now we have two types of microscope that we'll be dealing with. One is called the bright field microscopy. Another is called the polarized microscopy. So bright field microscopy is a very common and simple type of microscopy. Now why we call it bright field? Because the background is bright, but the object is dark. That's why we call it a bright field. Your field of view is bright, but object is dark. Therefore, there's a contrast between the background and the object. Therefore, we call it as a bright field microscopy. So here, what is the mechanism? The light, basically, it's transmitted through the specimen or the sample that we're dealing with, and therefore the contrast is basically generated by the absorption of light. Okay. Now, most important thing is that the major problem in bright field microscopy is that some color property must be there. There must be some color property if we want to visualize any object on a specimen using a bright field microscopy. If the property or a sample does not have color property, we will not be able to visualize. Why? Because the contrast that we want to generate will not be achieved if the sample does not have the chromatic or the color properties. And another limitation is that for weakly absorbing sun, that means if the sample absorbs very small amount of light, then definitely it will not be able to have a darker shade. That means the sample will also be bright and the field will also be bright. Therefore, we will not be able to distinguish which one is the object and which one is the background. So therefore, if the samples are weakly absorbing the light, then we will not have a good contrast. Contrast means what? It's a difference between the background. It's a parameter where it helps us to create a difference between the sample and the background. And also, resolution, you automatically know, is the minimum distance between the 2 points. So the better the resolution, the better the clarity of the image in the microscope. So if we go to the higher magnification microscopes, the resolution is very high. So bright field has a disadvantage. Now we come to the polarized light microscopy. So we know that you're already studying in first class, in theory class, that light is made up of two main components. One is called the electric component and another is called the magnetic component. So automatically what happens is that the electric component and the magnetic component, we know they are perpendicular to each other, right? But what happens, this is called an unpolarized light. Now when we are talking about the polarized light means that it will move through a single axis. So the polarized light actually helps us to visualize the image in a better way. So polarized images will give better contrast and better resolution than bright field microscopy. So therefore we go for two microscopy. There is the bright field microscopy as well as the polarized light microscopy. Okay. So the main thing is that the polarized light microscopes, how they work by converting this unpolarized light rays to the polarized light rays. And the most important thing is that the polarized filters, they allow the light parallel to their axis to only pass through. So therefore what happens, two rays are generated. One is called the ordinary and the extraordinary light rays. By the interference mechanism, what they will do, the background will be darkened in the polarized, but your object will get illuminated. It's just the opposite of the bright field. That's why bright field and polarized, they go hand in hand when we are performing the experiments.
Polarized light microscopy, they are only for crystalline material.
Okay, so like as you can see here, this is the configuration of a polarized light microscope. Already it's a light microscope only. What we do is already I've explained you the basic principles. So this is the basic system, and I'll show you how to use the polarizer, and we'll get a better contrast images. And this is the comparison. You see, in the bright field, the object will be darker, but the background will be brighter. But if you, in order to get a better contrast of the same field, we apply the polarizer, and then you see the crystal structures are extremely wonderfully visible against a dark background. That means the object is illuminated here. The object appears as a brighter one. This is the crystal structures, where the background is darker. So today our like experiment will be that the samples will be, we will deal with two samples. One is called the oleogel sample. So what is an oleogel? Basically, oleogel is a combination of oil and the gelatin. These are compounds that are now used in food and different industries, also even in pharmaceutical industries also. And then we have chocolates. You all eat chocolates, so we will do the experiment on chocolates and oleogels. Okay. And now what we will do is we will give you the QR code. You already have done the previous practical, so you have a lab test on that. After the lab test, we will proceed with the practical.
Demonstration give the demonstration.
Okay, I'll get demonstration. Sir.
One demonstration for the polarized and this thing.
Okay, sir.
So camera को on करो.
Camera on करो, sir.
Another important thing, I think we did a mistake in explaining the course. This fine, what do you call it?
We will delve deep into how can we analyze or how can we view the microscope images of any sample in a compound microscope. So here we will take an oleogel sample to see that how the crystals are being formed and how we can see the property of birefringence using the polarizer microscopy. So first what we will do, we will switch on the light that is present, so that the light already is on. Now what we will do, we are taking here the objective lens as 10x. So what we will do is we will press the slide. Now the thing is that first we have to adjust the stage in order to see our viewpoint, that is the field of view. And then what we will do, we will simply move the coarse adjustment, okay, in order to adjust the distance in between the objective lens and the sample. Okay. So as you can see from here, we have got a structure. Now we suppose we will try to see this particular view, irrespective of the artifacts that we are happening, that we're getting basically. So you can take any field of view, let's say. So you have to choose which is the best field of view depending on what sample you're dealing with. Let's say we are dealing with this type of sample. So this is a sample, let's say. Now you have to adjust the fine adjustment. See, if we move on the fine adjustment, see, it will get blurry. So in order to improve the clarity of the images, we need to go for the fine adjustment. And now you can see it's a clear image. But the problem is that in the bright field microscopy, the contrast between the crystals and the background is also clear. So in order to get a better image, what we will do, we will place a polarizer just above the illumination source of the microscope. So what we will do is we will simply put a polarizer, and now we will simply rotate until and unless the background becomes extremely dark, and then we can get the sample. So what we can do is we can decrease the light in order to get a better image. So for that, what we will do, we will again remove the polarizer and we will take the bright field image. So the thing is that in whatever intensity we are trying to take the bright field image, the same intensity will be used for your acquiring for the polarized image. But it's not always so. You have to adjust your intensity according to the sample characteristics or sample nature. Now, how will acquire the image? Let's say you want to acquire this field of view. So we'll simply click on this acquire image. So this is a Leica software. This basically comes with a microscope. So we'll simply click on the acquire image. Okay. Now it's already acquired. So we have already got the image. Now, okay. So now what we will do? See, we have got the image. So again we will go to acquire, and then we will get the field of view. Now what we will do is we will place this polarizer and we will try to find out which is the best view. Remember this, that your crystals will look brighter, whereas the others will look darker. So let's see that you can take any image depending on what sample you're trying to understand. See, the images are looking contrasting. Why? Because the crystals are birefringent in nature. So as the crystals are birefringent, so they will appear brighter in nature because they are diffracting the light that is coming from the incident source and from the polarizer, because polarizer creates a parallel vector. But the oil phase that is dispersed will basically helps to spread up the crystals, which will appear darker. So you can get a good contrast between them. So obviously this is just an experimental sample. You have to go for better sampling techniques or better sampling processes in order to get better clarity of images. So what we'll again do, we'll go for the acquire image again. Now the most important part when we are performing any bright field and polarized microscope is that whenever we are doing the bright field image, let's say we are just removing the polarizer now, okay, and we're taking this field of view. Remember that the field of view that we are taking for the bright field microscopy must not be changed for the polarized microscopy. We have to take the same field of view for both bright field and for polarized microscopy for better contrast and comparison. Because if we change the field of view, then simply the image will look fabricated, or your research paper or whatever work you're doing upon will get cancelled or not get accepted. That's why we need to understand that what type of sample it is. Based on that, we will apply the technique of sampling, that is making the side preparation. And always we have to understand that bright field gives a good image, but not as good as polarizing microscopy. Thank you.